Thanks so much for having me. I'm very excited about being here, and as always, to be beside Mesbah, talking about Circularise and digital material tracing with blockchain. So, yeah, we have two parts to this presentation, and this one begins with myself, called Digital Material Tracing with Circularise, and what we're seeing this as an enabling technology for circular economy. Yeah, as my introduction said, I'm John Fox from Covestro. I work in innovation and also in digital technology. So it's just another way of saying I'm not a chemist, although I'm from Covestro and we have strong chemistry knowledge. I stay on the digital and technology side of that. So just a quick intro about Covestro. Yeah, as we talked about before, we're the largest polymer producers, and for people who don't know what that means, we make plastics, and we help with the production of plastics. Our headquarters is in Leverkusen in North Rhine-Westphalia, and I'm actually a resident of North Rhine-Westphalia, although I'm American. And yeah, we have 17,000 employees worldwide, 30 sites worldwide as well, and we have three main business units: polyurethanes, polycarbonates, and coatings, adhesives, and specialties. We're also highly innovative, and what we've seen over the last few years is we're contributing to the circular economy through new technology for bio-based materials as well as recycled technologies. And because of that, we're actually really embracing circular economy, and we do have a vision for the company that we will be fully circular, and everything we're doing is moving in that direction to make that happen. This is a quote from our CEO, Marcus Steilemann. It's actually pointing out the value of plastics when they begin and also when they end up. And the problem is, if they end up in the environment, they're just sitting there and they're losing value. And this is one of these heartbreaking photos you see quite often. It's ugly to see this in the environment. It's not nice to look at, but we look at it from the standpoint of value. There's a lot of value in this, in what we could consider trash, that we need to clean up right now, but also we need to restrict that from actually gaining access into the environment through inadequate waste management. And this is where we start really embracing the circularity to keep that out. And we've done this because of it's not an easy job, as we all know. And so we're partnering with global agendas through these initiatives through Alliance to End Plastic Waste, with Circular Plastics Alliance. I'm actually involved in Alliance to End Plastic Waste. It's a great organization, and it's very knowledgeable people involved, as well as very passionate. And we're doing this because we understand that there's a need for plastics in the future for these different industries, such as automotive or construction or also electronics. There's definitely it's a necessity that has to be there. We just have to do a better job at keeping it within the loop and within the cycle, so we can continue to use them without just waste piling up. So at Covestro, we've actually created this idea behind reducing our footprint and being a producer of high performance materials. And this is put together as the reducer. And we have six like subcomponents of this, with renewable raw materials, recycled CO2, recycled materials, design for circularity, as well as renewable energy and production. And then where we connect in with Circularise is with the circular services. We'll talk about that more. Because what we've seen is with circular economy, there's been much of a priority, a very much a well-focused and much deserved priority on chemistry and the ability to understand how to collect raw materials in waste, to put it into the circle, to have it recycled. But what's kind of lacking in this is the digital support system. So are there systems available that we can use? And then below that, actually, the digital foundation. Is there a digital foundation that we can create that everything can kind of connect in with? Because this is only 5 pieces to the circular economy, but when you start talking about these subcomponents, and then within that there's more larger components, and then there's more players, there's more partners, there's more disciplines. It's a big challenge. So how do we keep those all together? And this is a great quote from our COO, Suchita Govil. She's talking about bringing our circular economy vision to life means finding courageous partners. And what we've seen so far is that it's courageous, it's innovation, it's companies that see the grand vision in circular economy. But as far as courageous goes, we definitely found one with Circularise. So we partnered with Circularise starting in 2019. Originally for the idea of we want to close the loop. We want to understand where our plastics are, we want to trace them through. So that idea of tracing was already there. But what really stands out for me, and also I think many people, is that they were already thinking about an open standard protocol then. So in 2019, we met them in 2019, so maybe in 2018, you're already talking about a foundational protocol to build off of. They weren't just saying, here's a solution that's a short-term solution to your needs. It's actually, let's develop a foundation, essentially, to be able to build things on top of. And so that's what we're really excited about that, and as well as smart questioning, which allows for companies to share private data on a public blockchain. And so when we start getting into the topic of transparency, this helps with the ability to do that, to be able to share information or share the information you would like to share without compromising any kind of secrets. And so when we started to work with Circularise, we were talking with companies, we were going on meetings, and we went to a meeting together, and this quote came out of that. And it came from the head of sustainability for a well-known brand. You would know it if I said it, but I'm not going to say it. And she said, "We hear a lot of talk about circular economy. It is great to see people actually doing something about it." And this is what was great about Circularise, and it still is today. You can start right now. And we have started. We're involved in multiple pilots with them, with companies that are engaged with us and ready to make that step. And it's not that we're delivering something massive. We're starting step by step, and we're taking our time to understand what they're capable of doing in learning and then building and learning. Because if you look at the circular economy model, there's these different components, and as you see, you have design, there's distribution, and others. But how do they communicate? Well, what's the glue holding that together? And we think it's transparency. You have to be able to communicate in these very different disciplines around the cycle. They're typically not connected. And so in this case, we need that transparency. And how do we get there? If we look at specifically at Covestro, this is a typical, kind of a simplified model of our circular value chain. And we're starting at the top, and we were moving around through the molder to an OEM or a brand, to a consumer, to the waste collector, and then hopefully back to us. But the big question here is, how does our material data find its way all the way around to the waste collector? How can it do it without it being compromised or losing it? Or how can it be trusted? How do we know this? And so the question really comes down to, okay, well, as the material goes around, how do you connect data to a physical material that's detailed enough that you can make decisions off of when you need to recycle it or sort it, and in that you trust it? That it's legitimate information. And that's where we start getting into the conversation of transparency. And that's the time I'm going to pass it over to Mesbah for more details into that. So.
All right. Great, John. Let me put up our presentation. All right, so hello everybody, great being here. My name is Mesbah. I'm one of the founders of Circularise. Thank you, John, for the great introduction. I think the importance of transparency for a better future, for a circular economy, is quite clear, as John stated. It's kind of a glue that holds everything together. This is something we figured about 4 years ago at the Delft University of Technology, where I was graduating, doing some research, and we found out that today a lot of products are not being recycled efficiently because we have no information, right? So this was for us the start of a journey to understand, like, why is this information not shared? I mean, somebody manufactured this. This is an example of a flat screen monitor being recycled in Italy. And these workers are taking minutes at a time to figure out if that plastic or if that product contains certain chemicals, certain attributes, looking for like flame retardants of specific kinds, looking for maybe hazardous chemicals. And it takes them a lot of time, and oftentimes they still don't know really what's inside. It's a lot of guesswork. So for us, we can't imagine a future circular economy without sharing more information about products. This is one of the main reasons in the long term to move towards better transparency. But another important reason is that we see a lot of brands and OEMs moving also very publicly towards making certain statements on their products, whether it's coming from recycled or renewable sources. And together with the third main thing that is driving transparency, which is legislation, which is coming very quickly in certain parts of the world, driven by consumers mostly and newer generations who are very conscious of what they're buying and where products are coming from. We see there is a big problem within the infrastructure that we have today. Essentially, if you're an OEM and you have tier 1, tier 2, tier 3 suppliers, the way to get information from that supply chain is sending emails back and forth, Excel sheets, PDF documents, to understand where something is coming from, how it was manufactured. And as you can imagine, this is very hard to scale. Takes a lot of time and resources, but it also leaves a lot of room for potential mistakes and even fraudulent stakeholders in that supply chain who might not always be as honest as we wish everybody to be. So in order to improve this, we have a system that is conceptually relatively easy to understand, I would say. So this is on the left, a very simple physical supply chain of two materials in certain quantities that go into two different parts that are manufactured, and then these parts are assembled into a final pen. So this is a very simple supply chain of a pen being manufactured from a raw material to a part to the final pen. What we create on the digital side is essentially a simulation of what's happening in a physical world per unique batch of material per kilogram. So you have a digital simulation of the actual physical supply chain. And this is where blockchain comes really into play, where every unit of that digital item, its balance and its ownership is tracked on a public blockchain. So we have 100% certainty that nobody can just change the information or alter it or double spend something they might have. And these digital units, as you can see from the image, are connected to data points and audits and certificates and other trustworthy data points to prove how they were manufactured and where they come from. So you might ask yourself, how does the two link, right? How does the digital link to the physical item? And that's where you have different models and schools of thought. And what we operate on by default is what we call a mass balance approach, where imagine you have a facility that buys 4 different types of materials. 2 of them are sustainable, 2 are non-sustainable. But these are exactly the same polymers, except for how they were manufactured in terms of based on bio, renewable, or virgin oil, right? So in this case, if you buy, let's say, 4 different units, we're not able to, within that facility, to distinguish the different units from each other. But what we can do is we can cap your output in terms of what you've bought in, what you've processed, and what the output can be at a maximum. So that's what we call a mass balance. On a facility level, we can facilitate this. A better step would be to do what is called an identity preservation chain of custody, a link between the physical and digital that is unbreakable. For that, you do need more than software, so you need to add something on top of this digital twin blockchain system. And oftentimes this comes in the form of a chemical tracer or an artificial DNA, if you will, that you can add to the batch and distinguish unique batches from each other and connect the identifier, the unique ID of the batch, to the digital identity on the blockchain. So the way we have set this up, and John gave a quick intro on that, is that we have been doing this on a public blockchain, so not appointing a central authority, not having a closed blockchain or a closed central system, having it a fully public, fully permissionless, everybody can look at it, but at the same time still protect everybody's privacy and confidentiality. These are two different things that are initially contradicting. How can you be more transparent and public while also being still private and confidential? Right, so this is where we have worked on from the university for about a 2-year time frame to get a patent on this specific application of showing information about a supply chain, certain private data points, without revealing any secrets on the public chain. And how this works conceptually is that instead of adding the data on the public blockchain, which is by definition almost compromised if you add the data, even if you encrypt it, if you give it enough time, somebody can decrypt that information. We don't add the information on any public system at all. What we do is we facilitate, using public information and reference data, facilitate a connection between two parties in a supply chain, so one party can make a statement and another can receive the statement's answer and verify its validity. Right? So you can prove as a supplier that you have not used a certain additive in a certain quantity, and a recycling company can then get an answer, get a statement, and see, using the reference data on a blockchain, that this statement is correct, but they cannot see anything behind it. So one of the nice things about this is that it allows companies to attach information to our systems without already knowing what kind of questions we're going to ask, because we don't know what information might be relevant for something we produce today. Like in 20 years' time, we might be, looking for completely different information we have no idea about. But if you connect your systems in such a way, the types of questions are completely dynamic, and we can change them over time without going back and manually doing a lot of work, right? So we make companies able to be transparent in a very flexible manner without already knowing exactly what they need to be transparent about, nor without really giving any of their secret data points to us or anybody else. If I go to the next slide, so this is really complementing the open protocol approach that John also touched upon, is that if you look at just the plastics and chemical supply chain, it's already so complex. There are so many different actors, so many different applications, from automotive, construction, textiles, electronics, all different kinds of verticals and different kinds of industries. Imagine having all of them run on the same system, right? So what we want to prevent is to have a winner-takes-it-all digital platform like a Facebook for transparency and industries, which is going to essentially dominate every flow. First of all, that's not very realistic. Supply chains are simply too complex and big to have such a system. Second of all, it's not really in anybody's benefit to have such a central power. Not even to mention the fact that it's contradicting the actual decentralization movement of blockchain. So what we're aiming for is to have an open protocol layer that is using blockchain, but everybody can build their own commercial applications on top of that. So similar to like email, it doesn't matter if you use Outlook and your suppliers use Gmail. You can still work together because they're using this open protocol fabric called IMAP and SMTP that allow companies to work together on the same level, speak the same language, even though they're competing on commercial levels. So this is really, really important to get to a mass adoption and prevent a winner-takes-it-all proprietary system. All right, so this sounds great, but how does that look like in practice? So I have a short video that I can run here that we published last year showing what we've done with, amongst others, Covestro and Porsche to track some of the parts of the Taycan all the way back to the raw material in the first proof of concept that I'm going to run now, and hopefully it works well.
A single car consists of about 30,000 parts if you count every nut, bolt, screw, and bearing. But when purchasing a car, do you know where each gram of material came from or how it was produced? Very likely the answer is no. Until now. A Porsche represents a lot more than the final car. It represents craftsmanship and an eye for detail. That includes how it's manufactured, down to the raw materials. And now, with the help of Circularise, car owners are given a glimpse into these details in the palm of their hands. They can see what the car is actually made of, where the parts are coming from, and what impact they have on the environment. All traced and validated on a blockchain-enabled digital infrastructure created by Circularise.
So we created this app basically because we believe the customer deserves to know what's inside the car. And we want the customer to learn about the sustainability of various parts.
On click, they see the certified sustainability information and the digital twin of the material and the amount that was used to build the car. This is the potential to significantly reduce the environmental impact. Circularise enables exactly this and can therefore not only help customers to learn more about their vehicle and its origins, but also help Porsche's engineers to make better decisions for the next generations of vehicles and support end-of-life recycling approaches.
All right, so that was a glimpse into how the technology can be used in practice and enable a level of transparency that is really unheard of before. So today we'll work with a number of customers in the plastics and chemical supply chain, predominantly polymer manufacturers, and then the different tiers all the way to different OEMs and brands. You can also see that in this slide where we have different applications of these plastics, but really have a core focus on this industry initially in Europe, but also in Asia as well as in the States. So that was it. Thank you very much. I'm looking forward to any questions that arise.
Yeah, many thanks. Interesting look in the future. And the questions we received have some partly already answered, but I think this is a crucial question here. How do you make sure that your solution becomes the one that is being used by all suppliers? What happens when stakeholders use other solutions? Or I would like to add, do you need a huge corporation worldwide to realize it? I understood your model, but there could be competition in different systems parallel.
Yeah, definitely, and I think that's exactly why we embrace competition with this open protocol, open standard layer, right? We don't think it's realistic to say that everybody in the supply chain is going to use Circularise. That's exactly the reason why we have this open standard, because that's probably not going to happen, right? So we will most likely need to cooperate with different types of solutions. And the only way we foresee that to really be able to do that without losing the competition is to change the competition to a different layer. Really have the competition on the commercial application layer and have the infrastructure be an open layer, right? So
I think the idea is brilliant, but in the past, as you know, this open standards has not so often worked so well. Email is a good example, it works. Yeah. But you remember perhaps that also there was a standard for Word texts in the past, a rich text format. Everybody could do the same with that, but it failed at the end because of some big companies don't like it. So it can also happen that you have different open standards parallel, and it could even be that one have a non-open standard. So what is your view on that? Yeah,
I mean, at the end of the day, it's up to the industry, right? So if everybody in that industry is okay with using a proprietary system, that's fine. I mean, we don't see that really likely and going to happen, just given the like, if you think about a supply chain, right? You've got the likes of Covestro, who are like multinational, billion-dollar revenue, like thousands of people working. But you've also got like family work, like facilities where they manufacture like injection molders. Like there's 20 people working there, right? So there is such a difference that sure we could have some sort of Google or Facebook type of solution that's going to dominate all of them, but we don't see that likely. Especially if you go to the first mile of where plastic, that's a waste, is being collected, right? So you're talking a completely different environment than to if you go to chemical companies or manufacturers and eventually even retailers and consumers. So it's I would say too complex, first of all. And then second of all, it doesn't make sense to strive for decentralization on a public system while keeping everything proprietary and closed. That's really, really not going to, you kind of lose a lot of the nice things about blockchain if you close it down and have it a proprietary system. So, yeah, I mean,
that's what we've seen when we're talking to potential customers and partners, is that there's just a different mentality there. And if you're, I hate to say old school, new school, but if you're stuck, and not that's bad, but if you're still thinking about the traditional ways of doing things, then it's not going to work, because you're still stuck in this just very essentially kind of linear idea where everything has got to be about the bottom line. And although we're in business and we want that, there's a bit of a layer there where we have to make some changes, and that's where this can fit in. It's also the fact that there are already some not competing open standards, but open standards for other things. So we see one for CO2, where it can fit nicely in with Circularize's open standard idea. And so it's very open. That's that's one of the benefits of this. You can see how you can build on it from a software perspective, but also from a data format perspective. And so it's so new. Everything's so new that you will just have to see where things are coming together, and then we can make decisions off of that. And I think most businesses are in that mind frame right now. We need to see what's next. And if something pulls ahead, they may jump on it, but they may just stand back and say, let's wait for a leader to emerge.
And also to clarify, like, we're a for-profit company, all right? So if somebody else comes with a open standard that is superior and is more adopted, we're going to be happy, because then we don't need to develop that, right? We're going to just use it, right? So at the end of the day, we are building a commercial solution on top of an open protocol that, I mean, we don't see anybody else doing that, so we're initiating that. But if somebody else comes with a better one, either we're going to work together or just use their standards. Like, it's about having a standard, not about who is like pushing the standard.
Yeah, I'm personally a great fan of open standards, and that is nothing so new. I think that's in the IT business since the beginning. Yeah, that's a fight between open standard and specific solutions. So I would be very happy that you will succeed with this basic idea, whether with your open standard or even better one. Yeah, that's a good idea. Yeah, we have new questions here. How does your solution helps to reduce ocean plastics?
Yeah, so that's a very, very complex topic, I would say, ocean plastics. One thing that we do see is that it's very hard to prove that something is made from ocean plastics at the end of the day, depending on where it's coming from, how it's been recycled, and what we want to prevent overall, not specifically for ocean plastic, but any kind of sustainably sourced plastic, is to be able to distinguish the real ones from the potentially fake ones, right? So either you have better transparency and efficiency to be able to prove those, or you might end up in a scenario where there is a lot of claims being made. Yes, this is ocean plastic. Yes, that's ocean, but nobody can verify them, right? So in that sense, it's going to help any kind of sustainably sourced plastic to get a better market value and kind of get a grip into the market, because you can actually distinguish them. How it's exactly going to play out with specifically ocean plastic it's a very complex topic, I would say.
Yeah. But I think you make it more easy to bring it back in the cycle, and so you will reduce the amount of plastics going to the ocean.
Yeah,
that is one of the basic ideas here.
Yeah, there's another point of, so what we're testing and what Circularize has made right now, let's just say it's the open standard software layer, and then what can be built on top of that. I mean, there's business ideas, there's concepts of things like tracing the material back for deposits. There's ways that you can incentivize the return of plastics, as long as it's, it has a QR code or has some sort of tracer that says this plastic is this valuable, then you already have a deposit system kind of on top. So there's a lot of different businesses that can be built on top of this open standard, not just tracing through the circle. There's business opportunities. So that's where there's still a degree of excitement on that side as well. So
there's a very typical question in this context. Is there a way to ensure that suppliers don't simply mislabel products or feed fraudulent information in the system? It's always a big question in those systems.
Yeah, that's a really, really good question, because just because something is on a blockchain doesn't make it true, right? You can also put false data on a blockchain. So that's why the first moment where new data enters the system for the first time, that's one of the weakest links and most crucial points, right? We have to focus a lot on that. And that's what I try to illustrate with that information is always connected to trusted data points, whether that's an auditor, a certificate, or other points of value that we know, okay, this information entered because it was said or signed by this type of company, right? So any information entering the system needs to come from a credible source. It can't be just self-reporting and everybody can just fill in whatever they want. So yeah, that's a really great question and also a really important point, because without that, you kind of still lose a lot of the value, because everybody can put in anything they want.
So as normal, it belongs on the details later, how to create the system. You've talked about cooperation with other systems. If you look for companies with sustainability certifications from feedstock, I take ICC from Cologne. We are not for failure here. Yeah. They also have blockchain technology for the feedstock, to follow the feedstock back to the field, for example. Do you already cooperate with them? Because the information on the feedstock going in the polymer production is a nice interface between both systems.
Definitely. So our system is designed in a way where it can work with these kind of certification schemes without necessarily having to do a lot of pre-work. So it can already work today with these kind of systems. Having said that, we do see a lot of benefits to work together. So yeah, today we're not necessarily working together with an ISCC or any other certificate scheme, but that is something we are exploring. So it's of high interest for us. Yeah.
Yeah, and Covestro, I think, anyway works together with ISCC, so it would be a small step to cooperate here.
Yeah, I mean, and we're already planning on including those certifications. They're publicly available, so we'll put them into the Circularise system. So when the material goes through, it's connected to that batch and to that material, and it's accessible. That certification, other standards that are. We're still working on the full data model that's available and what's necessary to go around the chain, but like we said, it's a very open system. So you just need to add more information. You can add more information.
Yeah.
And another question from my side is I'm also the initiator of the Renewable Carbon Initiative. So it would be also interesting to follow carbon.
Yeah.
There is a new term, carbon management. We have the fossil carbon. We have carbon from bio, CO2 and recycling. This three we call renewable carbon. Can your system also be used to trace the carbon, the source of carbon, and also where the carbon goes?
Exactly, definitely. I mean, today, most of the time, we're creating a unique digital identity for a kilogram of polymer, but we can also make it for an atom, right? There is no limitation in that. Like we can create it for a molecule. We can create it for every kind of granularity that we want. And just to, for the record, what we are creating is a layer to be able to communicate data from point A to point B very efficiently. Where ISCC is really good at, and other certification schemes, to be able to audit a facility or audit a certain location, and to be able to say this and this and this is possible here, and these are like the possibilities and the valid points, right? So you need both inputs to be able to do that full traceability. And I see a lot of these different kind of like open standards on how to do an LCA, for example. These are all really complementary, and we're not trying to do all of them. Really trying to make sure that everybody in the supply chain can communicate information from either point A to B to C very efficiently and trustworthy. Perhaps even an LCA can be based on your open standard data. At some point, yes. If you have enough data, you can. Yeah. I have to talk with my experts at home about cooperation here. Very interesting. Yeah, we have two additional questions now. How are you protecting the privacy of companies on a public blockchain? We explained this already, but please, this is a very important point, of course. Perhaps yes,
you can
this
also.
Is very, very important. Yeah, I can give a very quick a like sort of an analogy or an example where this works, and it's relatively easy to understand. So it's a cryptography field that is really novel and being adopted within the blockchain space quite often nowadays. It's called zero knowledge proofs, right? So it's a different way of, it's an interactive proof, right? So it's disconnecting knowledge from validation, right? So you can't validate something without having the knowledge. Previously, these two concepts were quite the same. Like if you need to validate something, you need to have the knowledge. But if you disconnect them, it's technically and cryptographically possible to validate something without having the knowledge.
But how is this possible?
Well, that's there's a lot of game theory behind it, right? Okay. So we can play a game, and if we play that game over and over and over again, at some point you're convinced that either I am the luckiest person in the world, and I've been like, it's the same as if I say I'm going to do a coin toss 100 times over, and every time it's going to be head. Like, what are the chances, right? It's like near zero. So you can play these kind of games, a lot more sophisticated with mathematics, to prove that whatever I say is correct. Otherwise, I'm the luckiest person in the world, right? So that's what's essentially behind it. And a more practical example would be, for example, in the identity space. It's possible, and there are some frameworks also in the Netherlands and other areas where you can prove that you have a certain age range without showing your actual birth date. So I can prove to you that I'm over 18 years old, but you never have to see my birth date. And we can do that by playing one of these games.
Interesting. I think one of the problems in the modern world is that we have too many decision makers with too low expertise. And I hope that this system will not go in this direction. Yeah, but we need more time to understand the details, of course. So it's a nice concept, but to prove it in detail, we need more time than we have today, I fear. We have another question here. Can you elaborate on how exactly the cycle will be closed with your approach? So what is it doing for circularity of polymers, for example? Yeah.
Right. So as we can. There's a few ways of doing this, but the most basic one we're seeing from the Covestro's perspective is that as materials entered into the cycle, it's traced. Let's say with Circularize's system, and we have a QR code on there. As it gets through to the end of into a sorter after it's gone through its use, they're able to then scan the QR code, and let's say. We know from that scan that there's certain material in certain areas. And by doing that, so let's say we have an agreement with some of the sorters and some of the recyclers. We can facilitate that, make more incentives as well for the sorter or the recycler to say, look, we've got Covestro material for you. Because what we see is that a lot of the current recycling is not suitable. And so what we want to try to do is find more suitable recycling streams and feedstocks using this material. So we know it's what it is. We know it's ours. We know it's, because if it's not suitable, it's going to require more energy to break it down and treat it. So we have to come up with plans, probably business arrangements with some of the sorters and the recyclers in order to say, look, we have your material. We're ready for that. Unfortunately, that might take years because of the high performance materials, but we're actually looking at this from a data perspective now, where there's without anything we've really talked about, there's really like a data strategy that is evolving, and we can start seeing where things are going and where they're moving and where they are. And so with that as well, we can kind of come up with some plans. We're still, again, it's still this infancy, to understand where in general the material is and how to get it back. So it's really having insights as well as just general business to say, well, we know that the material is ending up here 60% of the time, and if you have that material, we'll buy it back.
And the QR code is in the molecule level. It's not a normal QR code.
At this point, just because we're in testing, it is a QR code. It would be, yeah.
But with more pieces later, it's not easy to scan.
Yeah, exactly. Yeah. Yeah, exactly. So at some point, if it's a larger, if the laptop has one QR code, it has, it has everything in there, so you could see all the components. But until we get into to more of the molecular level, and I said DNA pieces or others, then we have to have that.
And then you can also trace how long your plastic lasts, because this is often a point forgotten in circular economy, that the best thing is to last long time, yeah?
Right.
Not to coming too early in the cycle.
Yeah.
And then with this system, you can also trace how long your material really lasts in the application or in the second application. That could also give some additional data to the circular economy and to
there's
CO2 calculations.
More insight into that. What was the previous usage? I mean, you get into there will be people that are interested in the history of the material, and so some. There's other things that might arise from having this kind of data, and we're still figuring that out, what that will be. If it's
one thing to add from my side, like there's this also this, this product as a service thing, right? Within the whole other movement, like why sell products at all? Why can't we just like be the owner of the polymers that we service to our customers? That would potentially like. Be a lot easier if you have that full traceability and a digital identity that you can connect and understand, like, okay, I'm Covestro, I'm selling these polymers to Porsche, but if you go on the road and there's like 100 Porsches on a parking lot, which one contains Covestro material and where are they, right? So you need to get that back in a PSS system. So
I think that the most important is that the polymer industry cares about what's happening with the products, because this was the last 20 years, I think a big mistake. We produce wonderful products, we don't care what's happening with them.
Yes.
And that was the reason why the image of the industry is such in a bad situation today. And now they're starting to care about what's happening. I think that is a very important point. And we have a last question from my side, then we go into the break. And if you have more questions, please send it to us, and also in the chat, and in the mini Mentimeter, because it will be answered later by the experts. My last question is, you talked it's important to have the information what toxics or what for components are in the material. But when I look in the future, I think there will be strongly chemical recycling coming, pyrolysis, gasification, and then to destroy most of the toxics. So is this information really so important for the future?
So that's what I say. We don't know what information is important for the future.
Okay.
Right? So instead of saying this is the right information that we need to have, we say if you connect your secret information without sharing the secret to us, we can make any kind of arbitrary statement later about whatever is going to be important later. But we don't know what's going to be important. Like today we asked certain questions, like we had no idea about these data points 20 years ago. So it would be naive to think that we already know what we're going to ask in 20 years.
I think that was a very good last comment. You are not only an open standard, you are open for everything comes in the future. What can be better? Congratulations and good luck for your development.